You must have seen a coconut, a dry coconut. This dry coconut is very hard on the surface, but it's very soft in the inner face. As shown in this picture also, if you break a coconut, you will find a very thin layer of hard surface as indicated by the dark brown line, whereas the inner surface is very soft as shown by the white area. So similar thing happens when you case harden any steel, whether it is carburizing, Carbo Nitriding, flame hardening or induction hardening. When you cut a section, you see similar structure. One area is dark and the other area is soft. So this dark area is known as case and the depth of this case is known as case depth, whereas the inner area is core. So what should be the depth of this case? That is known as effective case depth, which is very useful in case of designing any part by any designer depending upon the application of the part. So in this video I am going to discuss how to determine effective case depth in carburizing and Carbo Nitrided parts. I hope that you will like it. Please go through the entire video, see till the end. And if you like this, then you please like also, give your comment, and if you are new to my channel, then please subscribe also. So let's start the topic, how to determine effective case depth in carburizing and Carbo Nitriding parts, but after a short break. Hello friends, welcome on my channel Jagdish Chaubey. Metallurgical Quality Control Series 2, Part 7. In this video I am going to present how to determine effective case depth in case of carburizing or Carbo Nitriding parts. So let's move. First of all, flashback. Prior to this, I have already released 6 videos. Part 1 was your Germany hardenability test. Part 2, erection cupping test. Part 3, Charpy impact test. Part 4, Izard impact test. Part 5, inclusion rating of steel. And the last part was austenitic grain size. All these parts are very useful for any metallurgist or the person who are working in metallurgical lab, heat treatment lab. So I request you to go through all these parts to understand the basics of the metallurgy. If you have not seen these videos, please go back and see these videos. Okay. Now in this part, what I am going to cover. So what I will cover in this video, first is purpose, then test equipment, test method or procedures, precautions, problems and their possible solutions. Okay. So the first thing was purpose. What is the purpose of doing this test? Why we want to determine this effective case depth? So the purpose of determining effective case depth is carburizing or carbonated parts of steel is to verify and confirm effective case depth as specified by the designer depending upon the part application. Based on the part application, the designer decides about the effective case depth in any case hardening treatment, whether it is carburizing, nitrocarburizing or even flame hardening or induction hardening also. So we have to just verify or confirm whatever has been specified by the designer on the drawing about the E.C.D, whether it matches with that or not. So just to confirm, we do this test, determination of effective case depth in carburizing or Carbo Nitrided parts. This is the purpose of this test. Equipment. What are the equipments used? See, in this case you see the sample preparation equipments are all same, which I have earlier described in part 7 of MQC-1. Series 1, if you refer in part 7, you will find all these details. The difference is only in case of part 7 it was metallurgical microscope. Here I am using fully automatic micro hardness tester. It is just because of Vickers hardness. You have to check the hardness in Vickers. So in this case, you see this is a fully automatic micro hardness tester. Readings comes over here also, and you can see the impression. You can measure this impression on the computer screen, and out of this you can calculate the effective case depth. You can plot a curve, and even you can take a printout. So this is the usefulness of this micro hardness tester, which is being used in this particular test. Test methods. What are the test methods? So for detail, if you have to know in detail, then you go through this Indian Standard 6416/1988. Okay. So what are the test methods? See, there are 4 test methods. One is hardness test method, chemical method, then it's a macrostructure method, and the 4th one is microscopic method. How these are being done, I have shown it here. For E.C.D, because this video is on basically on E.C.D, so this I will be carrying on forward, and that hardness test method is used to determine the effective case depth. In rest of the cases, this chemical method, you generally determine the total case depth. How do you do it? You have to take, machine the sample at different depths and do the chemical analysis, particularly for carbon, and check the carbon content. Wherever the carbon content at whatever depth goes more than 0.04, then you consider that particular depth as total case depth. For example, if the base carbon is 0.20 and you are measuring it at different depths, and one particular depth you are finding it is 0.24, 0.04% more than the core, then that particular depth will be known as total case depth. In microstructure method, you do the fracture of that sample, and by seeing the dark area, you just decided that this is a case depth which you have achieved. But this particular process is used for routine process control. Means you, in between the process, you take out the sample, fracture it, see the total dark area, and if it is not up to the mark as you desire, then you have to further heat treat it again, and then again you have to see and confirm. So this is basically a routine process control method for determining the total case depth. Microscopic method. In microscopic method, we do for case depth of thin Carbo Nitrided parts. In case of very thin layer of Carbo Nitrided parts, you have to go through this microscopic, wherein you etch the sample with 2% nitrile and see under microscope, and then you see a dark and light area. So wherever there is no confirmation, because there is a transition area is there, that approximately taken as total case depth. So this is how total case depth is measured. But as an engineering design, E.C.D is more used, and in most of the cases it is being specified by the customer that what should be the E.C.D at particular load, okay, and for particular depth. So this what you have to consider, and I'll be going to only this E.C.D in the next slides. This again procedure. Again you have to refer the same standard, BIS Indian Standard 6416/1988, and the sample preparation technique almost again I have decided earlier also. Cutting, belt grinding, emery paper grinding, mounting, polishing, then etching up 2% nitrile, and then you see under microscope, and this your sample is ready for taking hardness measurement. So this sample is ready and you can go for further hardness check in Vickers hardness test. Okay, go ahead. So what is this hardness test, how it is done, this I have explained here also. In this case, if you see, keep the prepared sample, whatever the test sample you have prepared, the top surface, that you have to keep upward, and then apply the desired load at a distance mentioned in the slide 9. So you have to apply a load. This load should be whatever has been specified by the customer, or there is a general rule also that I will explain further. So this load is applied, okay, In the next slide, I will show you how it is to be applied. Check the hardness in VPN scale, then you have to check the hardness in VPN scale. Check hardness at equal distance from the surface as shown in figure. Again in figure B, I will show you how to check, what distance you have to check. Next slide you will see this. And then you have to plot a curve between hardness VPN and a distance from the surface. That is figure C again in the next slide. So this I am showing you, this figure is showing basically total case depth, and you see by the arrow it has been shown that a total dark area, black area is approximately total case depth of that particular part. Okay. Now as I told in the previous slide, how to measure this effective hardness. See, this is the entire surface, okay, entire cut section, and this is the polished area where you have to take hardness. So we have taken in two bands, one is this band and the other one is this band, and they are at different depth, D1, D2, D3 as mentioned here, and the distance between the center of the two impressions is also known as S. This is also shown here. Relation between D1, D2, D3, I have shown it here. You can see D1 should be 2 times of the diagonal length. This diagonal length, this is a square, and diagonal of this square is taken. Okay. So this diagonal length has to be multiplied by 2, and accordingly you can calculate it. Then S is equal to 3 times mean diagonal. Means whatever diagonals are coming, that value you have to calculate the mean diagonal value, and then have to multiply it by 3, and you get S. And D2 minus D1, it should not be more than 0.1 millimeter. This gap is also has to be maintained. So all these things you have to maintain while taking hardness. This is a very important thing, and all the necessary precautions you have to take. Okay. And then after that, then you have to plot a curve between VPN and distance from the surface in millimeter. And as per the customer requirement, if he says that at 550 HB, what is the effective case, then you have to calculate like this. So it comes 0.8 mm. Okay, the effective case depth will be 0.8 mm at 550 HB. But in other cases also it is taken sometime 513 HB also. At 513 also we decide about the case depth, but it all depends on the customer requirement. If he says, or the drawing it says 513, then you have to take 513. If it says 550, then you have to take 550 HB. 550 HB is approximately equal to 52.5 RC, and 530 is actually equal to RC50, Rockwell 50. In case of higher case depth, you can go even for HRC also, but the depth should be high. And then you can measure directly from HRC, and again you have to plot a curve and get the effective case depth. In case of low case depth, particularly in carbo nitriding and nitrided parts, the case depth is very low. If you go for a higher load, the load application is basically, generally it is 500 gram and up to 1 kg, but it depends again on the case depth. So load you have to select accordingly, and then you have to check it. For carbo nitrided part where the case depth is very low, if you go for a higher load, then you cannot get it because it will puncture the case actually. So then in that case you have to go for a lower load application, maybe from 100 gram to 500 gram, maybe 200 gram or 300 gram. But again, as specified by the customer. In all the cases, you have to go as per the customer requirement, because they are designing the part and they know the exact use of that particular effective case depth. So go as per the customer requirement. Precautions. What precautions are to be taken in this test while doing this test? All necessary precautions to be taken in sample preparation. Refer MQC-1 part 7. This again I am referring it. You have to refer by MQC series 1 and part 7, where I have already described all about sample preparation and whatever the precautions are to be taken. So I am not going to repeat it. You have to go through this video. Okay. For hardness checking in VPN, indentation must be made as directed in slide 9. Whatever in slide 9 I have directed, you have to go abide by that. The distance between the indents and the distance between the two center of the two indents, all these are to be maintained, D1, D2, D3 and S. So accordingly you have to check. This precaution is a very necessary. Otherwise, if the distances is very close to each other, if the impressions are very close to each other, you will not get the correct hardness. Okay. Now E.C.D must be determined at 550 HV as a standard practice, otherwise as per the customer's requirement. This I have again explained in this previous slide. The standard practice is 550 HV, and on that 550 HV, the load can be 500 gram to 1 kg or 2 kg. That's a different thing as is specified by the customer. But the case depth you have to take at 550. But if the customer specifies 513, then you have to go for 513 HV and then calculate the effective case depth. Then the last precaution is micro hardness tester or vigor hardness tester must be calibrated as per the frequency of the use. This is also a must, because there is a stage movement for the distance and there is a load calibration, because you are putting lot many loads also from 100 gram to even 1 kg, 2 kg. So that load must be calibrated. The distance and the movement of the stage has to be calibrated. So this calibration has to be done maybe in a year, depending upon the use, or at least 6 months. If you are using is 2 months, then the frequency of calibration should be 6 months. Otherwise, at least 1 year is a required frequency. Okay. Problems and solution. What are the problems that we face generally? The one thing is hardness indents are not clear. Generally it happens that visibility is not clear. Sometimes they are shaky and they are not clear, focus is not there. In that case, the only solution is that you have to take whatever necessary precaution I have mentioned in earlier. So in sample preparation, you have to take all the precautions. This will, if you take these precautions in sample preparation, you will not face this problem. Okay. Then indents are not perfectly square. This also happens sometime. First of all, the indents are not perfectly square. As shown earlier also, this has to be check the distance from the surface and or distance. All that D1, D2, D3, whatever I have described earlier, and S has to be maintained if you want to have a perfect square. Then hardness drops suddenly. Verify the microstructure should be uniform. This is a prime requirement. If the martensitic structure or tempered martensite is not uniform throughout the case, if there is a presence of retained austenite or otherwise structures, then you will not get a desired graph, okay, and you will not get a particular effective case depth. So for that, your microstructure has to be uniform. It means that you have to do this carburizing or whatever heat treatment you are doing. Proper carburizing or heat treatment has to be done so as to achieve a uniform case structure. Then only you can get, otherwise there could be a sudden drop in the hardness. So for this particular problem, this is the solution. So in this video, I have explained you all about effective case depth, how it is determined, what are the equipment that is being used, what precautions you have to take, and whatever problems you face in this and whatever the necessary solution for all these problems. So go through it, and if you like this video, if you are benefited out of this, then please like my video, share it with your friends, those who are in the similar occupation and service. And if you are new to my channel, then please subscribe it also. Okay. So the next video what I am going to cover is on effective case depth measurement in case of induction hardened or flame hardening. This is again the second part. First part I have covered. Second part is in part 8, effective case depth in induction or flame hardening. So wait till that part. Okay. So I must thank all of you for your patience listening. If I have made certain mistakes or committed something, please ignore it. But I feel this video will be very useful for all the purpose who are using and daily doing all these practices. Thanks for your patience listening, and wait for my next part, that is on effective case depth determination in induction and flame hardening. Thank you very much.